Welcome to Algebra 1 with Mrs. Carroll. Make sure you have a notebook for the entire year that you're going to use to take notes for all of your lessons, and pray before you begin. Warm up, okay? So in pre-algebra and below, you should know how to add two fractions. So I want you to pause the video and add 3/4 plus 2/3. And there's the answer. We call that the masked man, in case you've never seen it in some of my other videos. So basically, we kind of put little eyes on him here. Just kind of like a little eye here and a little eye here. He's called the masked man. Not a real good representation. But basically what it means is we're taking 9 times 3, or 3 times 3 and get 9, and 4 times 2 and get 8. Since these two, their LCD, or their least common denominator, is the numbers when they're multiplying the two of them. So if you multiply the two numbers to give me my LCD, my least common denominator, I can use the masked man as a way of doing it. So that ends up being 9/12 plus 8/12, which gives me 17/12, and I reduce that to 1 5/12. Hopefully you got that. There is a video down here I'll link for you to use, and that's a video that I created on what the masked man is. Okay, so Unit 1, Lesson 1, we're going to be talking about rational and irrational numbers. And in this lesson, we're going to be classifying real numbers as rational or irrational, comparing and contrasting rational and irrational numbers, understand and justify the sum and product of rational and irrational numbers with examples, and graph rational and irrational numbers on a number line, as well as identify and solve some absolute values. Okay, so some definitions that you may need. I'm just going to hit a couple of them. We have the absolute value, which is just meaning distance, so I can't go -3 miles. Rational numbers are just basically that. We're going to be talking about real, rational, integers, wholes, natural, and irrational numbers in a minute. Okay, so I'm going to hold off on those and give you kind of pictures to go with it. And algebra is basically the study of mathematical symbols and rules for manipulating those symbols. So welcome to algebra. So on this one, okay, I want to talk about what the difference between rational and irrational. First of all, real numbers are just that. They're both rational and irrational. They're just any number that's real. And any number that is rational has to be written as a fraction. Now the number 2 can actually be written as a fraction because it could be 2/1. So any whole number is a fraction as well, even though you don't realize that. You should know. So rational numbers are any number that can be written as a fraction. So 0.33 repeated is 1/3, and that is a rational number. In that rational number, we have what we call integers. Integers are 1, 2, 3, 4. We also have 0 in there, but then we also have the negative part. So we have -1, -2, -3. There are whole numbers going both directions, positive and negative. Whole numbers only go positives. They start at 0 and they count all the way up to infinity, but they don't go in the negative. Natural numbers are counting numbers, so they'd be the 1, 2, 3, 4. They just don't include 0. Now, irrational numbers, you should know the most famous one, which is pi, 3.14 ... And hopefully you've seen that before. If not, you're going to see that today. So here's a couple of questions, okay? Number 1, the set of 4, 5, and 11 can only be labeled as natural numbers. Is this true or false? So you have to decide. A number with a repeating decimal is in the set of rational numbers. True or false? Irrational numbers go to infinity and beyond. True or false? And categorize this particular group of numbers with a -1, a -0.33, the square root of 7, 14, 25.56. You may not get all of these answers, but by the end of the day, you will. Okay, the very first one, when we have it, is no. It is all the real numbers under rational numbers. So in other words, it's not only natural, but it's a whole, it's integers, it's rational, and it's real. So once we get to the middle in here, it encompasses all of those, okay? And then this one here excludes natural numbers, but encompasses all of those. Integers excludes whole numbers and natural numbers, but it goes all of those. Kind of get the idea. A number with a repeating decimal is in the set of rational numbers. that is true. If it's a repeating decimal, believe it or not, like 0.33 repeated, it actually can be written as a fraction. Number 3, irrational numbers go to infinity and beyond. Yep, they do. 3.14 keeps going. We still haven't found an end. And categorizing the numbers of -1 is an integer, okay? But negative 0.33 is not an integer, nor is it a whole number or a natural number. But it is a rational number. Now, the square root of 7, you don't know this yet, but unless it's a perfect square, it's irrational. So therefore, these are only categorized as real numbers, and that's all they fit into. Okay, one of the things I like to have in the middle of our class, usually toward the beginning of it, is what we call a God moment, okay? And rational and irrational numbers, what the world sees as rational is limited thinking, it's finite logic. What they think is irrational, God's unfailing love, is irrational to them because it's infinite and doesn't end. God's love for us doesn't end. God's it is beyond all rational thought. It just doesn't make logical sense to die for someone that hasn't even been born yet. But God, in His infinite wisdom, loves you irrationally by the world's standards. An irrational number is infinite and doesn't repeat. There is no worldly understanding of something that goes on infinitely. We as human are looking for the end, but we will never comprehend eternity without Jesus. And I love 1 Corinthians 1:25. For the foolishness of God is wiser than human wisdom, and the weakness of God is stronger than any human strength. So what is a rational number? Well, a rational number is an integer. So in other words, it goes in both directions as whole numbers, negatives and positives. Counting is 1, 2, 3, all the way over to the other direction with -1, -2, -3, and zeros in the middle. A fraction, 2/3. A repeating decimal, 0.3 repeated, or 0.6 repeated. Those are 1/3 and 2/3. Repeating or a terminating decimal. Now, a terminating decimal just means it ends. Okay, so 0.235 would end. And a perfect square root of 9, is 3. So be watchful for those. Your perfect squares are 2 times 2, which is 4. 3 times 3 is 9. 4 times 4 is 16. Hopefully you're getting the hang of that. 5 times 5, which is 25. Anything in between those numbers are not perfect squares. Alright, so what about an irrational number? Well, it basically is like pi. I mentioned that earlier, 3.14, and keeps repeating. A decimal that is not repeating or terminating. Basically, it goes on forever and doesn't repeat. A square root that is not a perfect square. Square root of 3, square root of 29, square root of 124. There's so many possibilities. Anything, as I said, that is between the square root of 4 and the square root of 9, square root of 6, 7, and 8, and even 5, would all be irrational numbers. Okay, with that in mind, I want you to look here, and this is what that notebook is for. You're going to write down all of your rational numbers that are here. Okay, so pause the video and see if you can figure out what a rational number is. Okay, so a rational number, remember I said terminating or repeating. It's kind of a little of both with a 0.2525. I did end it, but it also repeats. Or the 3.159,159. The 5/8 is a fraction. The 3/4 is also a fraction. Now, on the other hand, the square root of 6 is between the square root of 4 and the square root of 9. Therefore, it is not a perfect square. Square root of 31 is between the square root of 25 and the square root of 36. Also not a perfect square. And the decimal down below, the 2.3189 ... the 3 dots typically represent that it goes on forever, 3 or more dots. And you'll notice that there is no repeating involved. Hopefully you got that. So we're going to be talking about adding and multiplying rational and irrational numbers. So let's then have your thinking caps come on. Will the sum of 2 rational numbers be rational? So think of some rational numbers, some fractions and decimals. Will I get a rational number when I add them? So pause the video and see if you can figure that out and come up with at least one example. The answer to that would be yes. Now I have two examples that have fractions, like 2/5 plus 5/8, and I do get 41 over 40, which is 1 and 1/40. And I did use mixed numbers, which is 1 and 3/16, added it to 1, 2 and 4th, and I got 3 and 7/16, which is also a rational number. So yes, the answer to this is a rational plus a rational is a rational number. So what about the product of them? So if I times two fractions or two rational numbers, will I get a rational number? So pause the video and see if you can answer this one. The answer is, again, yes. So I took 2/5 in a same exact two fractions. I multiplied them, and I got either 1/4 or 2 and 43/64, which is basically shut down to a decimal, and you'll notice that. All right, so the answer so far is two rationals added and it's added and multiplied and subtracted and divided, just in case you didn't know, are all rational numbers. Okay, a little bit more. What about a rational and an irrational number when I add them? Will I get a rational or irrational number? Pause the video and see if you can figure it out. Give me some examples. Alrighty, so I took 3/4 plus pi, which of course is the 3.1415 ... and I get an irrational number. So the answer to that is no. A rational and an irrational will not give me a rational number, but will give me an irrational number, okay? And I took 19 and added it to the square root of 8, which is a number between the square root of 4 and the square root of 9. And I also got an irrational number. So the answer for that is nope, I get an irrational number. Let's try another one. What about if I take the product of a rational and an irrational number? Will I get a rational number? Pause the video and see if you can figure that one out. Nope, I won't. I will actually get an irrational number. So when I take 3/4 and multiply it to pi, it just makes it a bigger number that's, not a bigger number, but I mean it makes it a number that just keeps going on forever as well. 19 times the square root of 8 also gives me an irrational number. And a good way of thumb, and I'm going to go ahead and break this down for you, okay, is you may want to take a screenshot of this. I have a rational plus a rational does equal a rational. A rational times a rational does equal a rational. And a rational plus an irrational number does equal irrational, and an irrational times an irrational does give me an irrational number. And a good helpful hint, maybe help you, is irrational is like a lie. It corrupts all that it touches. Even truth with a little lie is still a lie. Just like irrational with a little irrational number is still an irrational number. Hopefully that reminds you of this. So now, hopefully you got that. And now we're going to talk about putting it on a number line. This is a little bit harder, so we have a couple things we may want to break it down. The first question I'm asking you is it an integer? So kind of think of it that way. Just look at it and say, is it an integer? Is it not an integer? Is it a rational number? Is it an irrational number? Where is it on the number line? Now I give you all the letters down there. There's 1, 2, 3, and 4. So good news, it's not anywhere higher than 4. And it's not in a negative, so that's always a good thing. Alright, so we're just dealing with positives. I want to see how well you do on where this actually is. And the very first one, example 1, I did give you 1.6. It's not an integer, because remember, integer has to be 0, 1, 2, 3, and the negative aspects, -1, -2, -3. It is rational, because it is a terminating decimal, okay? And if I look at it, it's about where h is. Now, I can see here, I want to make sure you realize that this is 1, 2, 3, 4, and then it's 5. So it's probably just a tad bit bigger than even this one. So hopefully that helps. So it's like, okay, so this would be 1.2, this would be 1.4, this would be 1.6, this would be 1.8, and that would be 2. Okay, so that may help you a little bit why it's actually on this line. Alright, pause the video, see if you can do it. It may take you a little bit. Hopefully you get most of them. If not, we will go over them, okay? So pause the video. Okay, the first thing you'll notice is there was only one integer, and that was e, the square root of 9, because the square root of 9 is a perfect square, so it would be 3. Now the irrational, I have a as a rational because it's a terminated decimal, and d is irrational because it's 5 over 3, so that's a fraction. And again, the square root of 9 is 3, so that's a rational number. The rest of them are all irrational numbers. Square root of 5, remember the rational times irrational is an irrational. That's what f would be. G would be the rational plus an irrational. And those are where they are on the actual number line. Hopefully you got those. Okay, so let's try this again on a smaller scale. Now you have to tell me, and you need to, on this number line below, you're going to draw one on the little notebook that you have in front of you, label it the -5 all the way to a +5 on a number line, and then you're going to just approximately put them in there because they don't necessarily, they're all rational numbers. So good luck with that. Pause the video. Okay, there they are. You only had to go up to -2 on one side and -4 on the other. Sorry about that. But there they all are. So not too bad. Hopefully you got all of those. Now let's try an irrational number. Now irrational numbers, remember, you're not going to get exact. So they are also going to be a little bit off. So draw a different number line and see if you can put these on there. Pause the video. Alrighty, so I have a 2 is there, C is the next one, A, 3, B, and 1, if you have it in that order, and approximately in between 1 and 2, 2 and 3, 3 and 4, and 4 and 5 for these guys right here as well as those. It's fine as long as it's between those two whole numbers. Hopefully you understand them enough now to do your homework. So, we're going to talk about absolute value. Now, it's like miles, as I said earlier when I was talking about the definition. You can't go -3 miles. Well, you could, but not really. It would be great, wouldn't it, if I could put gas in my tank instead of it always going out? Even when you drive backwards, your odometer is still increasing. So therefore, and it's still using gas, so therefore you're not going negative miles. So always think of the absolute value as a positive number. So the absolute value of -3 is 3, and the absolute value of 3 is 3. So they're not opposites, okay? What they show is the distance, okay? There's a couple of things that I want to make sure I point out to you, okay? And that is, if the negative sign is not inside the absolute value, then it would be a little bit different, okay? So in others, for if I had something like -3, well, this is going to be a positive in here, but this is going to continue to make it a -3. So be careful of that. It's a little trick one. You should have seen absolute values. That should not be anything new. Hopefully you saw it in pre-algebra. Alrighty, so let's take a look. I want you to pause the video and see if you can answer these. Good luck. Alrighty, so we have 4, 6, this is a -2 because it's on the outside. This becomes +2, okay? I want to make sure you realize this. This becomes +4, so therefore, since the negative is on the outside, it is not absolutely valued. Absolutely valued? I don't know. The point is it's still negative. Okay, hopefully that made a little bit of sense and you're able to do it on the homework, okay? Your homework in the Unit 1, Lesson 1 is on page 12 in the textbook and page 2 in the workbook. And oh, yes, one more thing. I like to always give you an exit ticket at the end, so we're going to do an exit ticket. And it says here, name all the number systems to which the number below belongs, okay? So we have the square root of 25. Is it A, B, C, or D? Pause the video. The answer is A, because the square root of 25 is 5. So it is a natural number, therefore it encompasses all the ones below it. Alrighty, hope you had a good time today and have a great day. See you next time.